So covalent bonding is our next type of bonding we're going to look at, and it's when we share electrons to create our bonds. So covalent bonding is the sharing of electrons between a nonmetal and a nonmetal. The charges do not combine to zero. Okay, so we're not trying to get to 0 or 8s in the charge section. What we're trying to do is we're trying to share so that at some point they all have 8 electrons. So, and covalent bonds form molecules, and we're all about sharing. Share, 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 share. You can think about it that covalent is like cooperate, okay? We're working together. So, how many bonds? In covalent bonding, the valence electrons are shared to reach the magic number 8. There are some exceptions. The first is hydrogen and helium because of the fact that they are in that first ring, and that first ring can only hold 2 electrons. Okay, so hydrogen will share so that it can get 2 electrons like that. The other one that is different is boron. There are elements throughout the periodic table that don't follow rules. Boron is was one that we happen to use often when we're doing assignments. Boron needs 6 electrons. 8 is too much for it, so it just needs 6. And it's because it's the fact that um, it's a metalloid, and so it's not following the trick of aluminum, which is a metal, and giving up its electrons. But it's not fully a non-metal where it's going to share. So helium, hydrogen need 2, boron needs 6. So to determine the number of bonds, we determine the number of valence electrons each atom has and subtract from 8. Okay, and of course, like I said, see the exceptions above. So group 4 needs 4, group 5 needs 3, group 6 needs 2, and group 7 needs 1. So there are 3 types of covalent bonds that we're going to look at in terms of the number of bonds. There's also types of bonds, whether it's polar or nonpolar, which we're going to talk about later. But single bonds are when 2 electrons are shared between 2 atoms. Okay, it's represented by 2 dots or a single line. Okay, so here's our example. Chlorine and chlorine, when they are attracted to each other, they're sharing these 2 electrons right here, and then these 2 electrons become a stick. Double bonds are when 4 electrons are shared between 2 atoms, and they're represented by 4 dots or 2 lines. Okay, so here we have our oxygen. Okay, and you can see here that they're sharing 4 electrons, or you have your 2 sticks in the middle. Okay. Triple bonds are when 6 electrons are shared between 2 atoms, okay, and they're represented by 6 dots. So here we have the nitrogens, okay. And what I'm talking about when I'm saying that they're sharing the 6, it means that each hydrogen at some point can claim them, and they would have 8 electrons around them. And so here it is when they have 3 sticks between. Okay. Some special covalent ions or molecules are called polyatomic ions. It's when multiple elements combine to make one ion, which we're going to use later in ionic bonding, okay, to make compounds. So these polyatomics are covalent bonded molecules that we use later to bond to a metal to make an ionic bond and to make a compound that way. And so they'll use the ionic bonds and the system of sandwich applesauce, the crisscross method. There are a list of common polyatomic ions, which we're going to talk about. We're also going to talk about them later when we talk about naming ions or naming compounds and molecules. But they're listed on page 7 of our chemistry reference table, and we're going to get more into that later. There's also a couple special atoms called diatomics. And diatomic atoms are atoms that they're elements that cannot be left alone. They have to be partnered with somebody. If they cannot partner with a separate element, then they will partner with themselves. Okay, and there's 7 of them. And they are hydrogen, oxygen, neon, fluorine, chlorine, bromine, and iodine. Those are our 7 that we need for the diatomic elements. And that's all I have for covalent, and we will talk about metallic in our next lesson.